String manipulation. String literal is where you specify the contents of a string in a program. This example here, you can see we've declared a variable, and then off to the right after the equal signs is the actual contents of the variable, and we'll call that the string literal. String literals can use single or double quotes. It does not matter, they just have to match on both sides. Apostrophes can be a problem with string literals. As you see here in the example, the apostrophe S is interpreted as the end of the string, and then Python does not recognize anything after the end of the string literal. Now we can solve this problem by using double quotes. And in this example, we use double quotes to contain the string. That allows us to use the apostrophe. Escape characters allow us to use a character that would otherwise be impossible to use for a string. In this example, we're going to use the escape character, and what that tells Python is that the apostrophe has no special characteristics. Treat it as just a string literal or just a regular character. Python has some built-in escape characters: the single quote, the double quote. The /t represents a tab, the /n represents a new line, and the double slash is how you can get a backslash in place, because by default the backslash is indeed an escape character. Here's an example of using the tab with an escape character. So we have the quick brown fox, and then we've put the tab character in there, /t, followed by jumped. And when we print this, we actually see the tab displaying in our output text. Here's an example using the new line character. Now we see printed the quick brown fox, followed by a new line, and then the word jumped. Here's an example of escaping the backslash. In the first line, we see that we're trying to specify a file path, but that's not really going to work for us, because what this is really doing is escaping the U, the E, the D, and it's not going to work for us right. So if I want this backslash to be used as an escape character, I have to come down here and use the double backslash. The first one escapes, tells Python that this backslash has no special meaning. Raw strings. You can place an R before the beginning of a quotation mark of a string to make it a raw string. And what a raw string does is it ignores any special characters. For example, in this example here from the textbook, you see that the escape character is treated just like any other character. And when we print this out, we actually see the escape character, the backslash, put in place. So how the format works is we put the lowercase r at the beginning of our string, and then anything within the beginning single quote and the ending single quote has no special meaning. Multi-line strings. We can begin and end a multi-line string with 3 single or double quotes. Multi-line comments. Begin and end with 3 single or double quotes. The example here shows double, but you can also use single quotes for this. You can index or slice strings. String indexes and slices the same way lists do. If you think of a string hello world as a list of each character in the string and an item with the corresponding index. Example of this: if I want to call any specific character of a string, the first position, position 0, is capital H. The last position, starting from the right, is the exclamation point. And then if I want to specify a range of characters, I can specify the start position, the end position. If I want positions 0 through 5, I don't have to put the 0 in there. I can just put the 5 at the right of the colon. And if I want to start at position 7 and go to the end, I can specify 7 at the beginning and then no end character. The in and not operators. In and not operators can be used to verify if a string contains specific text. In this example, we're going to use it to search if a multi-line string contains certain text. So if I want to see if a device is current, I can use the condition statement, if, followed by the string, is in, and version represents this multi-line string. And then what this will do is just simply print that I'm running the current iOS. And if I don't find this string within the output of this command or in this variable, then it tells me that I can print a statement here saying the device is not current. In this example, I'm using the in or not operators to verify a specific text again, but this time I'm going to use it to determine the model or the platform, the manufacturer of a device. And I can simply check if Cisco iOS is contained in the output of show version, then I can assume it's a Cisco device. If I find the string TMOS in the output of show version, then I know that device is manufactured by Nokia. I can also concatenate strings. I can create multiple variables, hostname, IP, software version, model, and then I can concatenate it using the plus for concatenation, and then I've put in some additional commas in here inside of single quotes, and now I can convert all of these variables into a single variable named line. Concatenating integers or floats can be problematic. You can't do it. So we have to call the string function right here to do that. So in this example, I'm trying to concatenate software version, and that's written as a floating point decimal. And it's not going to let me concatenate a string with a float. So one way I can get around that is I can call the string function here, and that within the concatenation, this gets converted to a string. But at the end of it, software version still remains a floating point decimal value. String interpolation is the process of substituting values of variables into placeholders in a string. In this example, I've got my same 4 variables as before, and what I'm going to do is I'm just going to create a reference. The %s is 4 separate references, and at the end of my string, I put the %, and inside of parentheses, I have to comma separate the 4 actual values. And when I do string interpolation, it will also take a floating point decimal and convert it to a string as well. I don't particularly like this method as much as I like some other methods for strings, but you do need to understand this because you will actually see it in Python documentation. Now when I do this with int and float values, here's an example of it. Here I've converted software version to a float, and when I interpolate it, it does indeed print for me, but it's still a floating point decimal. F strings, this is my personal favorite, and what I'm doing here is I'm creating the variable line, and instead of a R string as we did before, what we're going to do is we're going to begin our string literal with the F followed by a single quote, and then of course a single quote to end it. And I could use double quotes for this. And then each variable name is going to be placed within curly braces. And then the commas are actual string literals in this case. So I can comma separate variables using curly braces, and it does indeed go through the process, and it calls the string function on any floating point value as well. We have some other functions for strings, the upper, lower, is upper, and is lower. Now the is upper and is lower, what that does is that checks to see if a string is upper or lowercase, a string literal. Now if I want to convert something to upper, I can call the upper function, and what that does is it takes all characters of a string, all text characters, and converts them to uppercase. If you look here in the early example, I'm creating a variable called version, and that's a mix of upper and lowercase. Once I call the upper function, I've converted everything to uppercase. We have some searching functions, starts with and ends with, and basically what this does is it returns true if the contents of the starts with function, right here, if that's at the beginning of my variable, then that returns true. And ends with does the same thing, and we can check this way. And no, version does not indeed end with 6.5.12, it's 6.5.26. The join method is it's another way to concatenate strings essentially. So what we're going to do is we've got 5 variables here, and I'm going to join them, and in this syntax what I'm doing is I'm putting the separator in here. So between every variable I join, I'm going to put a comma, and then I'm going to join, and I'm going to create a list of all of the values that I join. And when I create the device info variable, it looks like this. I've got the host name, IP, manufacturer, and they are all comma separated. The split method allows me to take a multi-line or a large string and convert it into a list of smaller strings. Every instance of the argument to the function call is removed. This right here, when I call the split function, that's the argument that I pass within the function call. A new list element is created each time the argument is found. So what is going to happen here is I have this large string. Every time the new line character is found, it's going to remove that character, and then it's going to create a list. And if we go to the next slide, we'll see that actually in action. So here's an example of that code executing. And what we have is, as I've highlighted over version at the end of this, after the split function, you can see that I now have a list with 8 index positions. My length is 8, positions 0 through 7, and each line is now a separate list element. Removing white space. White space characters consist of space, tab, and the new line character. These are also called non-printing characters because they don't really appear when you print them. Strip removes all white space from the beginning and the end of the string. Lstrip removes all white space from the left, and rstrip removes all white space from the right. Now, if I want to use a strip function to remove text, I can just simply pass the text that I want to strip. And basically what I have here is I have a variable called version, and it has this text here going all the way to 6.5.26. If I want to remove everything up to 6.5.26, I can simply place that text as the argument of my lstrip function, and the result is only 6.5.26. Strip removes any leading spaces at the beginning or trailing spaces. The space is the default leading character to remove. Now let's take a closer look at this. The strip function removes characters. It checks each character from left or right and removes matches until it finds no match. So what this really means is, if I want to strip everything here, we saw this example already where I'm removing all characters, but what's really going on is it's checking every character within the single quotes, or within the quotes, doesn't have to be single or double, doesn't matter what order, but what it's going to do is it's going to check the furthermost left character. Actually, in this example, it's checking it from both sides, and it's looking for a capital C. If it finds a capital C, it removes it. And it's going to continue all the way down until it gets to a character that's not found within the function argument. In this example, 6, and the 6 over here, that's not found anywhere within my function argument, so those characters remain in place.